Okay, ladies and gentlemen, today we are going to finish chapter 1.4, which is about cells and batteries. Yes, we talked about dry cell in last class, but that is not the only type of the cells and battery that we use. Like for example, when it comes to car battery, we're using something I like to call wet cell because of electrolyte that is actually solution. Right. Let's look at the diagram on the right side. Probably one of the very first thing that you notice is we have some kind of solution. You can see the wave pattern over here. I mean, it generally doesn't go that fluid, but in any case, we have solution. Most of the time, it can be acidic solution if it's a strong battery, or it can be any type of ionic solution. The one thing that you need to know compared to the previous type dry cell, you still have two metals, ladies and gentlemen. One for positive, one for negative. So that part doesn't change. Electricity producing cells that use a liquid electrolyte that is usually an acid or ionic solution, such as sulfuric acid, we are going to call these type wet cells or wet batteries. A perfect example of wet cells are, like I mentioned in the previous slide, it is a car battery, the one that you use for jumping up the vehicle if your vehicle is discharged, those kind of thing. For example, if you run the heater or if you accidentally turn on the light for a night, something like that, know the fact that inside of there, you actually have sulfuric acid. Even though it's diluted, it's actually quite concentrated. Still, relatively concentrated. But one thing that is important is we have a lot of metal sheet and it's going to connect it to one end that has negative terminal, one end that has positive. That's where the positive is. You guys know positive, red, negative, black. Most cells in cars and trucks are wet cells, and wet cells produce way more electricity than the dry cell. And when it comes to wet cells and car batteries, just know that the red terminal and black terminals are covered by non-metallic cover, which is one of the reasons why this seems like plastic protective casing. Just for the heads up, if there's any type of leaking, please go to your vehicle service or dealership area ASAP. And you cannot drive your vehicle, you need to call the tow truck. There is definitely a good pros and cons, aka advantage and disadvantage, if you will, using wet cells. Number one, wet cells are cheap and easy to make. This is one of the big pros of using wet cell. If it's cheap enough, you can mass produce. On the other hand, because we're using acid most of the time, cons can be how can we dispose it well without affecting our ecosystem. This is more of a cons. We need to really take care of this wet cells because it's gonna spill, and if it spill, ionic solution or acid, if you don't have electrolyte, that means the circuit will be incomplete. Just for the heads up. So you may wonder, why do we use wet cells even though it is cheap to make and cost-wise it's more efficient, but why are we still using wet solution electrolyte inside of the vehicle where you have a spill problem, possibly? Because it's less likely to suffer damage from overcharging. So it doesn't get heat up that fast. Plus, it is quite durable. which is a fancy way of saying it's stable at one point too, protected, and you can use it for a long period of time. When it comes to wet cell, another cons, if you will, it is heavy. I don't know whether you actually lived that before or not, but wet cells have such a huge amount of acid and or ionic solution that it's quite heavy. And once it has a damage, it's really hard to clean things up also. And electro zinc and copper, those are also heavy metal area. Electrolyte normally eat off the zinc. So as time goes, one of the electrode will get lighter, and this is one of the reasons why your battery need replacement several years after using that wet battery inside of your car's engine area. Sorry, next to engine is there's a battery, but hopefully you understand what I try to say. The copper electrodes are not eaten away though. In fact, when it comes to these guys, it builds up. So it gets even heavier. So one side get eaten, get lighter. When it comes to the other side, it gathered, it gets heavier. Alright, so first thing first, how can electron move in wet cells? Because electron cannot travel through the solution. We need something to complete. Electrons travel along the wire from negative zinc electrode to the positive copper electrode. So as you can see from this diagram over here, electrons are moving always one to another direction. Sadly, it doesn't go backward, which is one of the reasons why zinc will be eaten up and then copper will get fatter. So far, we went through two different types of cells and battery, which is dry cell or dry battery and wet cell, wet battery. We didn't really go through the difference between cell and battery, even though I mentioned cell as a basic unit and battery is plural stack of cell like double-decker, triple-decker sandwiches. Cells are one single unit of chemical reaction that generate electricity, which is made of plastic. An individual cell is lighter but not as powerful because it's a single unit. Batteries are plural. Those are stack of cells. So the how battery works. First of all, we have negative electrode and positive electrode. Like I mentioned, consider zinc and copper. Zinc is the one that get lighter and eaten up as time go. Coppers are the one that get fatter as time go, and that happened because electron is only one direction. Go from zinc to copper. It doesn't go to the other way naturally. Also, you need to know that electrolyte has to be present. Either dry electrolyte or wet electrolyte, doesn't really matter. In this picture is wet one. One electrode, in this case zinc, has to be negative, another positive. Sometimes when it comes to wet cell, instead of sharing one container and I have a little boundary in between, you may see a little bit of a bridge, which people call salt bridge. When they mention about salt, it's more ionic solution. It's not actually sodium chloride table salt, even though you can kind of use it anyway. One thing that I will tell you is if that happens, can you see there's zinc electrolyte? You gotta use zinc ion solution. On the other hand, if I use copper, you may guess I need to use copper solution. That's the only difference. In grade 9, fortunately, you don't need to memorize this kind of type, except just know that some cells have boundary and have a same container. On the other hand, two different containers connected with the bridges, that's also possible. In cells, there is something I like to say as primary cell. The word primary generally used as priority, number one, those kind of thing. Primary cell cannot be charged. What I mean by that is it's one-time usable or battery. So what I mean by that is once it's discharged, completely, that means it's going to become garbage. Secondary cell is, imagine you can use more than one time. Secondary cells are, sometimes we call it rechargeable batteries. So any batteries that are rechargeable, like for example, your Chromebook, phone, car, etc., etc., those are secondary cells. The thing about secondary cell is, yes, you can recharge it, but as you know, it have a life expectancy. What I mean by that is, most of the time phone, if you use every day, about 2 years, 3 years, then the battery will die pretty fast. Like some of your phone. You may notice a new phone can last for about 24 hours easily, but after 2-3 years, it may die off in 4 hours, if I exaggerate a little bit. The thing about rechargeable batteries and rechargeable cells, what you need to know is they use specific chemical. Nickel oxide, which is known as NiO, solid, and cadmiums, those are the one that people use a lot. And combination of these two chemicals are used quite a bit in secondary cells. And even rechargeable cells wear out over time, like I mentioned. It will die off pretty easily, or extreme situation, you have to charge it 24/7 because its life is so low. This section, I want you to probably pause it after each because you need to copy quite a bit. Primary cell is a battery that is designed to be used once and is discarded. It is not rechargeable by even external electricity. We cannot reuse it. An electrochemical reaction that occur, it's not reversible. It's a fancy way of saying whatever the reaction happened, it's gone, like combustion reaction. Secondary cell, on the other hand, it is a battery or cell that can be recharged once it's discharged entirely. You can recharge many times because the reaction is reversible. And large batteries, ladies and gents, contains quite a lot amount of cells. So let's think about this a little bit. You can even perform this, which I don't recommend because it produces hydrogen and oxygen. You can separate water into elements, but electrolysis is a process that splits molecules into their elements. We call it simple decomposition reaction. So for example, water can turn into oxygen and hydrogen. Balancing part will come out later, so I'm gonna go through that after this. So electrochemistry was used by Humphrey Davy to separate potassium and sodium and other elements from the ore. So what people use is they try to have a pure element. For instance, if I have sodium chloride, I can make it melted and turning into liquid. And if I apply some polarity, I can have sodium, I can have chloride, except as time goes, it's gonna turning into its own pure chemical, something like that. We use it to produce chlorine to make drinking water safe also. Chlorine has disinfectant effect. If you watched a movie called Martian, and which I hope English class go through that as a novel study, electrolysis of water produces fuel for the space shuttle. And the way that it works is space shuttle can use pure hydrogen gas because remember it's combustible gas, and they can just separate hydrogen and oxygen from water to produce some kind of explosive gas collecting again hydrogen and use it for extra fuel. When these two gases are mixed and ignited, they release tremendous amount of energy. This part you can actually double check the movie Martians because there is a section where he's so fearful about the outcome of the combustion just because the gases will create a lot of energy and he is limited to a certain area. He doesn't have any other place to go. That's the reason. Okay, I want you to look at the picture on the right side. Let's see. Can you see that oxygen occupy this much? On the other hand, hydrogen occupy that much. I want you to think about which one produces more during this electrolysis process, which is again, you can think of simple decomposition or producing pure element. You may notice that hydrogen amount way larger. And we are going to discover why hydrogen is actually produced way more compared to the oxygen. And again, if you watch that Martian movie, you already know the answer for that actually. There are two explanations, one grade 9 explanation and one grade 10 explanation. I'm gonna go through both. First of all, water. If it's separated, you know that one of them is hydrogen, another is oxygen. This is word equation. What I'm writing in blue is grade 9 explanation. I want you to think about water structure, which you should know, H2O. Which means technically it's H2O1. This should explain about the ratio because hydrogen, I have two of them, oxygen, I have one of them. So the ratio is 2:1 ratio. This is grade 9 way of explaining things. On the other hand, as soon as you go to grade 10, you guys will learn about balancing, which is not that far away from what we did anyway. H2O water turning into H2 hydrogen, O2 oxygen. Can you see that left side and right side is not balanced? The reason being is oxygen, I have only one of them on the left side. I should have two on the other side. So what we do is we put 2 in front of water. Then 2 times 1 give you 1 oxygen. That's good. But now hydrogen is affected. 2 times 2 is 4. So I need to put 2 in front of hydrogen so that the ratio is 2:1 ratio. And this is grade 10 way of explaining why water, if I separate the element, hydrogen and oxygen have different ratio, 2:1. The other technology that you need to know is something I like to call electroplating. Electroplating is coating a metal or material with another metal. So if you look at one on the right side over here, you notice that copper, if it's anode, the electron go from one end to another end. Can you see that copper become thinner? The reason it's thinner is because some of the copper went to the other metal, and this create copper plating. If you think about very expensive vehicle, chrome plating is what people use a lot because chrome is an expensive matter, but compared to the others, and also it's durable. It doesn't get rusted easily like iron. Less expensive jewelries often do gold plating, so it's not pure gold, it's just gold film. And the way that it does, instead of copper, imagine gold. You may wonder how electroplating works. It's actually quite simple. Whatever the matter that you like to coat, you need to put it on cathode side. This will be coated. Whatever the one that you attach to anode side, this will be used. So I just need to put anode as gold if you want to do gold plating or silver plating. Because the metal at anode wide wears off to coat another metal at cathode side, this is a technology that I like to go through and actually demonstrate to you, hopefully, when you guys come back from online. We're almost done. Anodizing, it's another similar version of electroplating. It is an electrochemical process that converts the metal surface into an oxide layer. So I'm gonna highlight this. Oops, of course. So imagine when it comes to copper, oh, of course, copper turning into copper oxide. If it's lead turning into lead oxide. Anything that has oxide, you may know, where does that come from? Well, yeah, it's come from oxygen. So imagine by putting electrons around, you are coating a pure metal with oxygen. If you do that, the thing is, it actually becomes corrosion resistant material. So a lot of matter that you're dealing with that is you think it's pure metal, it's actually not pure. It has some oxide layer. You can even paint on it too, or sometimes it's already have a distinct color like this. People who like building stuff or who like to shop in Home Depot and help your dad building some stuff, you may hear about galvanized nail. Galvanizing is the process of immersing iron or steel in a bath of molten zinc. Do you guys remember that? In previous slide, you have zinc electrode. And do you remember that zinc electrodes are the one that eaten away in a battery or in a cell? So that means, if you think about it, we are actually having protected layer by using zinc layer to protect whatever the steel inside. So galvanized material look like this. It's way better quality than paint, obviously, because you guys know paint will be basically run off and then it's gonna expose the metal inside. Galvanized, on the other hand, because you're putting in molten zinc, it has a layer. So for example, imagine you have a nail. Doesn't look like, but there you go. There's a groove. This itself, imagine it's iron. But iron is the notorious one that undergoes some kind of a reaction with the air and water. It's gonna turn into rust. You know that red rust? So if I dip it inside of the zinc, molten zinc bath, then zinc solid will be coated. It looks exact same color as iron, except this is gonna be the one that protect the layer. So I want you to really carefully observe if you go to Canadian Tire or Home Depot and actually look at galvanized nail. Sometimes people use this electroplating technique to purify stuff. So for example, let's say This is AJ's statue. Copper statue. That's worn out, it's really old, we gotta refine it. Then what you need to do is, well, have a pure chunk of copper on one side, negative side specifically, and then make whatever that statue or any type of matter that you like to refine it and make it look pure, put it, then what's gonna happen is some of those chemical will come out like zinc, nickel, those kind of stuff that you don't want, but pure metal will be the one that's come out, which is copper in this case. We are not doing this for obviously the Statue of Liberty because it's too darn big. That is everything, ladies and gentlemen. Your homework portion is doing all science log activity that is accompanied with this. I'd like to go over those questions on the next class, and that's how I'm going to begin.